My dear students, now we are going to look at a two variable K-map. So two variable K-map, the name itself suggests that there are only two variables. Let's say variable A and variable B. Let's say output is Y. So I have a function with two variables. Let's say 0, 0, 0, 1, 1, 0, 1, 1. For which the output is something like this. Let's say this output is 1 here and 1 here, 1 here and 0 here. So what I am trying to do is I am looking for reducing the expression for Y. Actually, I can write like this. This is A bar B bar and this is A bar B. This is A B bar. So what I am trying to do is if I write the expression for Y is it is A bar B bar plus A bar B plus A B bar. The meaning of this is Y equal to 1, Y equal to 1 when A0 B0 or A0 B1 or A B0. A is 1, B is 0. So this we can implement it with logic gates. Of course, it is possible. Now what I try to do is we will use the K map and we try to see what exactly we can do with respect to the K map. What is K map is a systematic approach of representing the same table such that without applying any Boolean laws. Okay. By using principle of adjacency, we are trying to reduce the expression. What is principle of adjacency? Principle of adjacency. Adjacency. Okay. So principle of adjacency, what it says is something like this. If you have A B bar plus AB, what I can do is I can take A common and it is B bar plus B. Now it results in A where I am able to reduce, eliminate or cancel B. So let's take something like this. A is MSB, B is LSB, 0, 1, 0, 1. If that is the case, 0, 0 is 0, 0, 1 is 1, 0, 0, 0, 1, 0 is 2, 1, 1 is 3. This is one way of representation. The other way of representation is like this. Okay, where we are writing A here and B here, 0, 0, 0 and followed by 1, followed by 1. This is 1, this is 0 and this is 1. So once again I am taking 0, 0, 0, 1. So 0 and 0. So this corresponds to 0. A is MSB, right? 0, 0. 1, 0. What is 1, 0? 1, 0 is 2. Then what exactly? 1, 0. So B is 1, A is 0. So it is 1. Then 1, 1 is 3. So this is how exactly it will be. So what exactly that I am trying to do is we can map this, the whole thing. Now A is mapped over here, B is mapped over here. Because of this, these inputs 0, 0, 0, 1, 1, 0 are mapped into cell numbers. This 2, for example, if I take 2, the value 2 is mapped over here. Value 3 is mapped over here. Value 1 is mapped over here. Right? Now value 0 is mapped over here. So for 0, now K-map in K-map consisting of what exactly? Input variables and input combinations. But how input variables and input combinations are arranged? They are arranged such that there is a principle of adjacency is maintained. What is the principle of adjacency? Where if I combine them, I can reduce the variables. So the whole set of inputs, whatever we have, the whole set of inputs table is mapped into K-map. The whole set of outputs are mapped and will be loading into the cells. In what way? For 0 it is 1. So for 0, 1, 2, 3. For 0 it is 1. For 1 it is 1. For 2 it is 1. Right? For 3 it is 0. Okay. So what I can do is I can work with min terms or max terms. So I would like to work with min terms. Let's suppose. So what I try to do is I'll combine these two. They are adjacent. I can combine with these two. They are adjacent. Okay. So what exactly this is? 0 and 1. A is changing. So A got eliminated. So what is this? I left with is B bar. 1 is B bar. So in this is B bar. And what about this? Plus, in this B is changing, A is 0, so A bar. A is 0 means A bar, B is 0 means B bar. So what I can say is, it is A bar, the output expression Y is A bar plus B bar. Okay. Now let's look at the same solution in another way. So if you enter into the same map, now 1, 1, 1, 0, right? So instead of working with min terms, if I work with max terms, I can combine these two. What I am going to get here is, I am going to get the expression for y. So what I can say is, this is a table for y. What is the meaning of k map? It's not a table, I can say it's a map. So k map is for the output values. So output values, we are going to get output expression. The map is representing inputs. So you are going to get output in terms of inputs. So on the whole, what I can say is like this. What I am going to get here is, it is A bar plus B bar. Why it is A bar plus B bar? Because it is a max term. So when it is 1, it is A bar. It is also 1 plus B bar. So either you solve like this or you solve like this. You are getting the same thing. Okay, this is what exactly with respect to two variable K map. So in two variable K map, what are the possible combinations that we will come across? The possible combinations that we are going to come across is, let's suppose all ones. Let's say it is A and this is B, this is 0, this is 1, this is 0, this is 1. So one possible combination is quad ones, 4 ones. 4 ones means that function, let's say this is for function sum f1, function f1. So f1 is equals to 1. That means f1 is 1 always. What is the meaning of this is, let's say I have AB and function f1 0 0 0 1 1 0 1 1, for which always function is 1. When always function is 1, 4 cells are 1. When everything is, so when quad, when 4 cells are combined, how many variables I can eliminate? 2 variables I can eliminate. So we have 2 variables A and B, and A and B is eliminated. So we left with f being always 1. Okay. So f is always 1. This is what exactly the thing that we have got it. Right. Now what is the other possibility for a 2 variable K map? For a 2 variable K map, when we are working, the possibilities are like this. Okay, A is MSB, B is LSB, let's suppose. Okay, what is MSB? Most significant bit. What is LSB? Least significant bit. Let's say this is 0 and 1, this is 0 and 1. So 0, 1, okay, when MSB is 0, when MSB is 1, 2 and 3. So what are the possible ways we can combine is, one possible way to combine is these two and this two. Okay. What are the other possible ways? The other possible ways is, I can combine these two. Okay. I can combine these two with this two. Okay. Any other possible combinations? Or I can combine all four. So This is what exactly the principle of adjacency. So 0, 1 are adjacent. Okay. 0, 2 adjacent. 1, 3 adjacent. Cells I am talking with respect. 2, 3 adjacent. Okay. These are the adjacents. Is 1 and 2 adjacent? No. 1, 2. If I take 1, 2, it is not adjacent. 1, 2, not adjacent. Say 0, 3, not adjacent. So whenever it is not adjacent, you are not supposed to combine. So you can combine 0, 1, you can combine 0, 2, you can combine 1, 3, you can combine 2, 3. Okay. So what is the meaning of that is, what is illegal in case of 2 to 1, sorry, 2 variable K map, where I have A and I have B, this is 0 and 1, 0 and 1. Combining like this is illegal. Combining like this is illegal. Why they are combining like that is diagonally illegal is they are not adjacent. What is mean by they are not adjacent is they are not going to vary by only one variable. Example, if I take this, what is this exactly? A0, B0 means it is A bar, B bar. If I take this cell, it is AB. So if you compare AB and A bar, B bar, okay, I am comparing with cell 0, cell 1, cell 2, cell 3. 0, 3 are combined. 1, 2 are combined. Compared. So what is 1? What is 1 is, what exactly? Is A bar B, and what is 2 is A B bar. Okay. So what are the changes? How many changes you have? From A to A there is a change. For B to B there is a change. A to A there is a change. B to B there is a change. So they are not adjacent. If there is only one change, okay, it is they are called adjacent. Say for example, I have A bar B bar, then which is 0, then 1 which is A bar B. Let's say A bar B. So there is only one difference. What is that? B is changed to B bar. So I can take A bar common, B bar plus B, I can eliminate it. So this is what exactly the adjacency. So what is there in map is, it is a systematic approach in which we are keeping the min terms in a particular fashion, that is nothing but using a gray code, unit distance code. Okay, from cell to cell there is only one variation. Okay, so the cell to cell wherever there is only one variation, okay, we can combine them and we can get the reduced expression, which is a process of reducing the number of logic gates, logic expression, area. Okay, what exactly the intention behind this? We would like to reduce the expression. If you reduce the expression, what you will get? If you reduce the expression, you will get less number of logic gates. If you get less number of logic gates, so it becomes what your cost gets reduced, area gets reduced, okay, power gets reduced, okay. So this is what exactly the thing that we are looking for. Okay, for this process we are using maps. So out of that we have seen all possible combinations how exactly we can work with two variable K map. Okay, in the next class we will see the three variable.